Chapter 7, Section 3, proving that a quadrilateral is a parallelogram. This is really just a lot of realistic application to Chapter 7, Section 2, and what they're going to give you is some specific shapes and ask what the values might be if that is a parallelogram, or they might give you something and ask what property it is. So let's say I have a shape that very much looks like a parallelogram. And let's say these are 60 degrees and these are congruent. Okay, so that tells me that my opposite angles of my quadrilateral are congruent, which makes this a parallelogram. So the proof in this, or the statement that would prove this, is opposite angles of a parallelogram are congruent. Now, there are some of you that are sitting here going, Mr. No, can I just go back and put the number, the theorem number? And I want you to write these out because we're going to have to write them out when we do some proofs as well. So to answer that question, no, you cannot write out the theorem. All I want you to do is write it out in words, please. Okay, that sounded a little confusing. Let me rewind. I don't want you to just write the theorem number. I want you to write the theorem statement. Okay, so writing out in words. So if I had some kind of wild and crazy parallelogram that looked like this. Ooh, I know. There you go, Mr. No, getting all crazy again. And let's say I had some x's and y values. Let's go. This one is 4y. This one is 2x. Let's see. Y plus 87 and 3x minus 32. Y plus 87. And what did I say the other one was? 3x minus 32. And if we're going to solve for x and y in this case, the question they're going to ask you is what values of x and y would make this a parallelogram? Well, if those are opposite angles, they have to be equal. So I would set 2x equal to 3x minus 32. I would then set 4y equal to y plus 87. And then I would solve those. Subtract 3x from both sides. That gives me negative x equals negative 32. If I multiply through by negative 1, that tells me x is 32. They might also ask you to put those back in and find the angles, but we're not going to do that in this case. And then in this one, we're going to subtract a y from both sides. That gives me 3y equal to 87. Divide both sides by 3. And that appears to be 29. So y equals 29. Again, just practical application of Chapter 7, Section 2. So this is a real short one, proving that a quadrilateral is a parallelogram.